my name is Avery. Today we're going to start looking at TidyVerse in R and learn about some data management and data cleaning techniques using the packages in TidyVerse. So first, if you don't have TidyVerse installed, I have commented out the line of code which will let you install it, install.packages, and then TidyVerse. Once you have TidyVerse installed, we're going to load it in with our library function. So the dataset that we're going to use today is one that's already built into R, so you don't need to download anything to follow this tutorial. If we want to look at some information about that dataset or any function in R, just a reminder that you can put a question mark and then type what you want to learn more about, and it'll pop up in the Help tab over here. So this is a dataset about Edgar Anderson's iris data. Irises are flowers. And as we can see here, it has 3 species of irises and information about sepal length and width, petal length and width in centimeters. So let's go ahead and save this data set into our environment. I'm going to call it first iris. And if we want to start exploring this data set, the easiest way to do that is to just go over into our environment and click on it, and it'll pop up in a new tab over here, and we can see the whole data set. But we also have some functions in TidyVerse that will allow us to get different views that might be a little quicker or more helpful. So first we have glimpse, so we can see in the console that this gives us the data type for each column, number of columns, number of rows, so that's good if you need that information. And then head will give you the first 6 observations in the data set, and it has a little bit less information if you just want to quickly look at what information the data set has. And then summary will give you the basic summary statistics for each variable in your data set. Okay, so now we'll get into some specific functions for data cleaning and data managing. All of these are in dplyr, which is within TidyVerse. So the first one we're going to look at is filter. So filtering allows you to keep certain observations in a data set based on a condition, and that uses logic. So we'll be using greater than, less than, greater than, equal to, not equal to, and in operators for this function. So first, let's say we want to use the filter function to only keep the Setosa species of iris flowers. So first we have to specify which data set we want to use, which is iris, the first iris that we had saved before, and then the name of the variable that we want to filter, which would be species, the flower species, and then we can put Setosas. And as you can see here, it pops up in the console that now the dataset only has Setosa species. Now you'll notice that in that first example, since there's only one condition that we're filtering on, that I was able to use the double equal sign to set species equal to Setosa. But if we want to keep multiple species, we're going to use an in operator, and we'll make a vector. So what that in operator is doing is it's saying species, and then it's looking through this little vector that we're going to make and checking if each observation is in one of those. So let's do Setosa and versicolor. And now we have both of those flower species. As I said when we were looking at the data set, there's 3 flower species. So now that we have 2, in other words, we have all but 1. So we can use not equal to as well and type the name of that other flower species, which was Virginica. Did not work because I spelled it wrong. I feel like the most common error ever. There you go. Syntax errors. We can also do filtering for numeric variables. So if we want to keep petal length greater than 1.5, we'll just put greater than 1.5. We can also filter for multiple conditions at once, and our OR and operators are helpful in that. So if we do our AND operator, that means that we're only keeping observations that are both not Virginica and petal length is 1.5, and then with the OR, it's either or. So we can see in our environment that there's a different number of observations here because of that change in logical operator. But we don't need to use a logic operator because R will default. R does have a default in the filter if we just use a comma instead. So let's check it out. And it looks like we have the same number of observations in the AND. So let's confirm that it is defaulting to AND. And look at our help section for filter. Okay, here we go. It says, if we go down to the example section, it has exactly what we just did using the AND and OR, and then it says when multiple expressions are used, they are combined using AND by default. So if you ever have questions or are wondering what a specific function does, you can always refer to that help section, and you can usually find the answer there quickly. Okay, the next function we're going to look at is select. So select allows you to keep specific variables or columns, and it will get rid of the other ones that you don't specify. So let's keep species. Species, length. This doesn't need to be in quotation marks. Okay, so now we've just kept species and the length. And then the next function we're going to look at is mutate. Now mutate can do a whole bunch of things. Mutate just allows you to change a variable, and so that includes making new variables, renaming variables, changing the properties of a variable. There's a lot of things you can do with mutate. We're not going to get into every example of what you can do with mutate, but again, you can go and look in the help section and see all of the different things you can do. So first, I'm going to make a petal area variable with mutate. So we'll do area equals petal dot length times petal dot width. And now we have a new variable, area. Okay. We can also, as I said, change the names. This method of changing the names, though, will also keep that original, as we're about to see when I enter it in. It's just making a new, what this logic is doing is making a new variable that has essentially the same as the original one. So it's kind of just making a duplicate with this method. Here, we'll look at that. So yeah, we have the original petal length, petal width, but now we have these shorter names as well. So a better way to do that would be to use a function called rename. that as it states, renames it. So we'll enter it the exact same, but this time it will replace the title of the variable instead of copying it. And here you can see now we just have length and width instead of both. Now that we've got a handful of functions in our little toolbox here, we can do multiple of these functions as once if we connect them with the pipe operator. So what this is going to do is it'll read something. For example, let's start with our data set, and then we pipe it. So it'll take first iris and then we'll filter. Let's do species not equal. And then we pipe again, and we can do another function. So let's do select. Actually, let's do mutate and make that area one. Just gonna copy this. And when we pipe it through, now we don't have to specify the data set because it's specified up here. So the logic of this is we have our data set, and then we're filtering that data set, and then it's tacking on each individual line of code here. So first we're filtering, and then we're doing mutate, and then we're doing rename. So I saved new iris over here. As we can see, we have all of those changes that we just specified all at once in one line of code. Okay, the next function we have is group by. So this is going to group by a specific variable. So we can see here that our data set doesn't look any different just by using that, but group by will be important once we start doing statistics with our data. So the next function we're going to look at is summarize. So summarize will produce different statistics that you specify with it. So first let's do mean. I didn't specify what we were taking the mean of. Let's do the mean of area. Okay, so the mean area for all of the observations in our data set has been produced in the console here. We can also relabel it, the output of it. So instead of having mean and then area, we can call it area mean so that it looks a little cleaner, or you can call it whatever you want. And then the end function will give us a total. So now we see that we have 150 observations. So now let's use group by and summarize together, and we'll see that the group by shows you each statistics by species because they're grouped together. So let's do area mean, area median, standard deviation, and total. So as I said before, the pipe function is gonna do each step in the order that you specify. So let's see if this will still work if we switch the order of group by and summarize. And we get an error. So yes, the order does matter. We can't group by after the fact, or we won't get the summary that we want. The last thing I'm going to show you is that if we use the cross function within summarize, we can specify that we want to get the summary of everything, or get the statistic for all of the different variables is what that everything is doing. And let's do mean again. So those were all of the basic functions in TidyVerse that are commonly used for data cleaning. There are other ones, and I'll actually supply a link of the developer's website that shows you all of the different data cleaning functions within TidyVerse and gives a little summary as to what you can do with each of them. Thank you.